Hi, I'm Dave Triano, President of Shadow Composites. Welcome to the third tape in our Advanced Construction Techniques series. This tape is on vacuum bagging. A lot of misconceptions are floating around about vacuum bagging and its proper uses in a rocketry context. From my experience in the aircraft and marine industries, vacuum bagging should be understood from the start is a very useful process for a number of reasons. When you want to do a curved part, okay, and you have a mold, we'll say for instance a boat hull, there's a couple ways you can do it. You can get in there and just apply your reinforcements and just kind of let gravity do its job and let them sit there. Or you can get in with a vacuum bag system and you can actually compress the laminate together. You'll recall in the first tape that we did, we used the heat tape method of compaction to compact and bleed the excess resin out of a laminate. When you're vacuum bagging, you're doing the same thing. You're trying to balance and obtain that perfect balance of a 50-50 resin to reinforcement ratio. That varies a few percent for specific reinforcements, of course. But it's all the same thing. You use vacuum bagging on shapes that you can't do otherwise. The heat tape obviously works very well for tubular structures or for square section structures or triangular section structures, something that's got a consistent shape along its length. Vacuum bagging is used when you've got compound curves. It's also used to advantage when you've got a flat surface, okay, to create flat stock from. What we're going to do in this video is do three different types of vacuum bagging applications. We're going to do a flat laminate in which we create some carbon fiber sheet stock. We're going to do an actual full-size Astro BD fin which has shape all the way around the whole fin. It's a three-dimensional fin. We're going to create half of that in a vacuum bag mold, and then I'm going to show you the finished fin created from both halves of that mold. Then the third project we're going to do is we're going to do a nose cone. We're going to vacuum bag into half of a nose cone shape. And I'm going to take you through each of these little projects, and these should cover most of the unusual or strange things you've heard about vacuum bagging. You'll get to see details as I work through it, just like we do with the other projects. Vacuum bagging is just like what it sounds. You're applying a vacuum to a part that's inside of a bag. What you're doing is evacuating out the air and letting atmospheric pressure compress the laminate for you. Okay? Now, in order to do that, you have to have your part inside of some sort of enclosed area, something you can pull a vacuum on. This is accomplished traditionally with bags, hence the name vacuum bagging. When you're looking at vacuum bagging, this is where it gets its name. This is the bag material. Comes in a number of different types of material, but it's all, very similar. It's a plastic type of sheet material. What it's made to do is usually withstand heat and withstand pressure and not puncture or not leak, not let that vacuum loose, okay? This is the actual bag material. This usually forms the outer skin of the vacuum bag structure. Now, when I refer to a vacuum bag structure, what I'm referring to is the combination of materials that make up this whole vacuum bagging system, okay? There's guys out there that have actually vacuum bag tubes with good results, and they've gotten the hang of vacuum bagging by putting one layer around a tube or something. Vacuum bagging, in my opinion, is not really made for doing those tube structures, okay? It's got a number of problems inherent, as it leaves seams where your film is going to wrap around and come together. It's going to leave a seam on the tube, things like that. Tubes are much better done with a tape wrapping technique. Vacuum bagging of a flat laminate structure is the easiest way to show you how all of these different materials work together to compress that, and how they work together. So let me just take you through the basic materials involved in what you're going to be doing. First of all, you're going to have a work surface, okay? The work surface can be a mold. The work surface can be, as in this case, a flat plate of glass, all right? I'm going to be creating here a flat laminate, a sheet laminate of carbon fiber. What I want to do is have a totally slick, nice, hard, level, flat surface to vacuum bag to. Glass is ideal for that. Obviously, glass is flat, glass is slick, and when I apply a release to it, the material should come off fairly easily. So that's what we want. It can also be a mold, a shaped mold, okay? It can have a little relief, it can have a lot of relief. The third project that we'll do, the nose cone, will have a lot more relief than this, of course, because this is flat. But what we've got here, I'll just explain, is a basic mold base for doing a flat structure laminate, okay? What I've got here is a particle board base, okay? To that, I have used silicone to just bond a sheet of 3/16 glass. No other reason than just to stick it to it, okay? On this sheet of glass, I've placed a strip of rubber all the way around, okay? This can be rubber, it can be wood, it can be anything. This is called a resin dam, all right? The easiest way for me to show all of these materials working together is going to be to actually do it and explain the usefulness of each specific item as I go through it. So that's what we're going to do. This resin dam is just like what it sounds. It's a dam meant to minimize or try to inhibit resin from flowing out of the part and into your vacuum system that's going to be pulling the air out of it. This other material you see around here is a vacuum tape. It's a sealing tape to which the bag will affix to and make it airtight. So what we've got here is a glass base, right? We've got our resin dam and we've got our sealant tape applied. The sealant tape is kind of like silly putty, except it's very, very sticky, and it's actually about 1/8 of an inch thick, so you can compress down a vacuum bag into the material and it will keep air from going into it. It has this release tape on top of it right now, so I don't stick everything on the table to it. It's very, very sticky, so we'll just leave that down right now. What I'm going to do first is just get a little of our release agent. This was the same PTFE release agent that we used in the last video for releasing our tube, and we'll just give this a good spray in the area of the laminate. This is going to make a sheet of carbon that's roughly about 12 inches by 14 inches in size, okay? That laminate is going to sit in this area inside of the resin dam, okay? We've got a little bit of room between the part and the resin dam. You'll notice what I've got here to begin this laminate is some of our carbon fiber non-woven material. This is the 1 ounce material that we sell. The 1 ounce material and also the carbon glass hybrid in the thicker material is very good at creating a smooth surface. In a lot of times people will notice in their vacuum bagging applications or or even when they've made flat parts by stacking up carbon fiber and then weighting them down between 2 layers of glass or something like that, you'll notice that the carbon fiber weave in a plain weave fabric won't get all filled in with all the resin. That's where this type of material comes in handy in vacuum bag applications. This creates a smooth surface structure. It obviously doesn't have that weave pattern, so the resin is just going to smoothly impregnate this. We use this on the bottom and on the top of our flat structure laminate. In the middle will be sheets of our 8-ounce carbon fiber plain weave fabric. Okay, let's get right to this. We've got the release coating down on our glass surface. We've got our properly proportioned air epoxy. I'm just going to paint a layer down right on the surface. I know about the size of my laminate that I'm going to get, so I'm just painting down just a decent layer right on there. It's a little bit chilly today, so it is has thickened up the air epoxy. It doesn't really matter too much because I'm going to be getting this under the bag, and then it's going to go into the curing oven to cure. So during that whole process, the resin will actually heat up a little bit. It'll flow through the carbon, and it'll all become a nice homogeneous unit. So there we've got resin down. Now we'll just go directly to a piece of our non-woven 1-ounce carbon. All right. Now we'll just work this down. All right. Down. Not worrying too much about full impregnation of it. Like I said, it'll flow out later, but I'm just getting a good amount of resin into the mix, in between the layers. All right. All right. So now we'll add our first layer of carbon fiber, the 8-ounce plain weave material, right on top of the non-woven. I'll just get that down. I'm going to have to mix up some more resin, so I'll just continue talking about this as I mix the next batch. You can see this is obviously a flat laminate. Flat laminated carbon fiber is kind of hard to come by. We do sell a 1/4-inch autoclave carbon fiber that's about the strongest material you're ever going to see. The fins on our Trinity demonstrator rocket and on the joint Cosden and Shadow Composites project was composed of this 1/4-inch autoclave carbon fiber, and obviously survived the 40,000-foot Mach 3 flight with no problem. So very, very strong stuff. If you want thinner amounts, we do make an 1/8-inch plate for use in our Raven kit and shock value kits, but we don't sell that to the general public. So you're going to need to make your own plate material, which leaves you with this technique. It's a fairly straightforward process to get yourself set up with a vacuum bagging setup, okay? Obviously, what you need is the materials that I'm going to show you, and you'll need a good amount of them. A lot of the vacuum bagging process is strictly disposable. The bags and everything are one-time use only. So you'll need a good supply of all of these materials that I'll be going through. You'll need a good vacuum as well. A lot of guys adapt vacuum pumps out of refrigerators, which are just fine. You can do that. we tend to use a little heavier duty kind of unit like this. This is a Thomas pump. It's a very simple intake exhaust pump on an electric motor. It really is a good area for those who like to tinker, or those who like to come up with simple mechanical contraptions. Knock yourself out, you know. Get a decent pump that will pull, you know, 27 inches of vacuum if possible, and just do it. So, okay, just getting the air epoxy mixed up again. There we go. You will also need, obviously, a vacuum hose that connects your vacuum pump to the part that you will have under vacuum. And then you'll need another piece, which is a vacuum takeoff fitting, which I'll show you in more detail when we get to that point in this first laminate project. Okay, so that epoxy's all nice and mixed up. So we'll keep wetting out these layers as we put them on. I like to use this glass table also because it's reusable. You know, as long as you've got a good release agent on there, you can just pull plate after plate after plate of this material, and you know, that's the inexpensive way to make some good carbon fiber sheet. When you're putting the layers in to this laminate, you want to pay attention to the direction of your fibers. All right. All of these fibers in these layers that I'm building up are going at 0 degrees and 90 degrees. Okay, that's where I want the strength directions in this specific plate. If you want a plate with strength in all directions, then you should vary the direction of the fibers in these layers at 45-45 in a couple of the layers. That'll give you strength in all directions. So that's a little bit of composite engineering as far as you need to anticipate the direction of the loads that your structure is going to encounter and create your structure to handle those. So there we've got a second layer of the 8-ounce carbon right on top of the last one. You usually want to allow a little bit extra space on the edge. You want to make a plate a little bit larger than you'd like, because these edges are not going to be the same material as what's in the center. You know, they may have a little bit less material, you know, or they may get a little out of alignment during the vacuum process. That's, you know, so allow yourself a little bit extra larger size when you're designing your whole table to make these. Okay, just getting a good amount of resin on there. Don't be too concerned about just getting that right resin ratio like we were in the tubes. And vacuum bagging is a process. It can be a process of bleeding off excess resin. It's usually a process of bleeding off excess resin while you compact the laminate. It doesn't have to be. It can be, and this is what we're going to show you on this first one for sure. But now we've got a third layer of 8-ounce carbon. All right. And those 3 layers are on top of the 1-ounce carbon bottom layer. All right. So I get this third layer down. Just looking good. You can get some incredibly strong plate structures made this way. You can use glass, you can use Kevlar, you can use a lot of different materials in this manner. You can even bond pre-cured sheets or layers of plywood together using a vacuum bagging technique. You're just using it there to create the force to hold them together, of course. But very handy way of doing things around the shop. It's like with the curing oven. It just enables you to do many, many more things. And when you have these kinds of fixtures and tools around the shop, you know, sky's the limit on what you can make, and we'll show you that today with some of the parts we've got. This is the final top layer of the laminate, and it's another layer of the 1-ounce carbon fiber. All right? So we'll just make sure we'll use the rest of the resin that we've got here and just get it all down on the structure. All right. This non-woven carbon fiber likes to soak up resin, and you'll see it very clearly. It's actually like a resin sponge. It's fairly light material, so it's not going to soak up too much resin, but it soaks it up a lot easier than the woven cloth will. You'll see that for sure, which is another reason why it gives that smooth surface finish. So there we've got a laminate, okay? That's a carbon fiber plate laminate, right? We'll toss this epoxy, and now we'll get to what comes next. You'll recall in the last video, if you have that video, we did a Mylar wrap tube to get a smooth, slick surface on that carbon fiber tube. We're going to use that same 14 thousandths thick Mylar. This is it right here. And you see what I'm going to do with this plate is I'm going to do 3 different techniques to give you 3 different effects on this plate. So I've got a portion of this is the 14 thousandths Mylar, which I'm going to spray with the release material. Okay. That stuff is great. It's you know, it works that fast. Now it's ready to release. So I'm going to put this face down over 1/3, or about that, of our structure, or plate. All right. The next portion is going to be peel ply. This is the nylon material that we also used in the last video. It's good for bonding, secondary bonding. If you want to bond something to this plate or bond this plate to something, you want this texture on there that will give it the bite for the adhesive to bite into. And you see, that's how we apply that. We just lay it down on the structure, and then you can take your brush just to smooth it out if you need to, if there's any wrinkles in it. But what it'll do is it'll actually melt kind of into that structure. Not melt, but it'll soak down into that structure. The resin will soak up into it. It'll become a part of that structure until we rip it off later. So we got that. Now the last portion I'm going to show, this is called a perforated release layer. All right. This, being a release layer, will rip right off of the finished laminate. Okay. It's not going to stick to epoxy. It's perforated, meaning when I lay this down onto a plate surface like this, there's little perforations that are all on the surface. What is that going to do? In the next step, the next material we lay down is called a breather bleeder layer. It's like cotton batting that some women might be familiar with, and some men for that matter, from sewing or from making pillows, things like that. It's a cotton layer about 1/8 of an inch thick, just in random fashion. This, being a breather bleeder layer, when you put this down on top of that perforated material, it allows the vacuum bag to stand up off of that surface and allows air to be sucked out. It also allows resin to be sucked out and into the bleeder layer. Okay, so it serves two purposes. It allows the air, you know, it doesn't allow anything in this to stop the airflow. So it allows the vacuum to reach all parts, all sections of the part. and then it also soaks up that excess resin. Excess resin will go through those perforations and into the bleeder layer. After you tear off the perforated release layer, then you're left with a structure underneath that has a resin to fiber ratio that's much, much closer to 50-50. You can take that too far, however, and cure a part under vacuum or too high a vacuum, and with too many perforations, you can suck out too much resin. So there is a fine line that does, you need to be aware of. So we have that. We've laid down that bleeder breather layer on top of our 3 different materials. What we want to do now is take our vacuum bag. And what I mentioned earlier, the part about the vacuum takeoff fixture. What I have here is a vacuum takeoff fixture. All right? This part goes, the bottom part will go inside of the bag. Okay? This part, this plate portion. This will go inside of the bag. On top of the bleeder breather layer, it's going to be the conduit through which all the air comes through from the inside to the outside. And this is the top portion, which is on the outside of the bag, attaches through the bag to the bottom portion. It's got a rubber section here, and I usually apply some petroleum jelly or there's silicone grease, something like that, to it to keep a good tight vacuum between it, the bag, and the bottom layer. What I've done with my bag here is I've essentially cut a cross pattern into one area on it. I'm going to put the bottom section there, and the top section will go through that cross pattern. It's just big enough to get the center of the valve or the vacuum takeoff fixture through. Then I turn it and lock the fixture into position on the bag. So now I've got an airtight gateway from the inside of the vacuum bag structure through to the outside. You'll notice also when I did my resin dam, I left enough area up here so that my vacuum takeoff valve has enough room to live in there between the sealant tape and the resin dam. The resin dam now, you see, is between the vacuum valve and the laminate. The resin is going to be soaked out of the laminate, hit that resin dam, and the resin dam is going to hold it back a little bit. Not completely, but it's going to hold it back enough so that the resin is not sucked into our vacuum hose and into the vacuum, which would ruin all the equipment. So the resin dam is very important. Another thing that's very important is you'll notice got the breather bleeder layer down. I cut a few more layers of that, little squares, and I put it directly beneath where the vacuum takeoff fixture is going to go. In between these valves are little pieces, or in between these layers of breather bleeder are also little pieces of vacuum bag. This is all in an attempt to keep resin, if it does get through to this point, from getting into the vacuum takeoff fixture and getting into our hoses and our pump, which would ruin them. So that's just a little pad built up for the vacuum takeoff fixture. We put that down. We've got our bag. Now I'm going to take off these gloves, and we're going to get in here on one corner, and we're going to start to remove this protective tape from the sealant tape. All right? We will get one corner going, and then we'll just work our way around the fixture. What we're doing now is essentially sealing off the bag. This sealant tape rests directly on the glass, and it will connect directly to the bag. Air can't get through the glass, air can't get through the bag. We will have an airtight container with our laminate inside. So I start at one corner, and I just move right along, and I'm sealing down the bag to the tape. All right? With this type of laminate, you don't have to be too careful about getting too many wrinkles in this bag as you put it down, because it's flat. There's not a lot of stuff going on. As we do molds with more curvature and more form to them, you'll see we'll actually need to allow more bag material in here so that it can suck down into there. All right? We don't need to do that with this one, but you'll see what I do. We're just working around, making sure we don't have any air pockets working their way to the outside, and we're rubbing it down on the sealant tape. Okay? It's going all the way around. Now what will happen when you get back to where you started is you will usually have too much bag material left. And you're thinking, well, how do I get that bag material to stick down without having any channels of air to the outside? Well, that's what we're going to show you right now. What you do, let me get it to that point that I'm talking about first. But just working our way around. Okay, almost there. So you see what I was talking about. Look, we've got this much space to go and this much bag. Well, that would obviously make an air channel. What you do is you take a little bit of the vacuum sealant tape, right? Just going to take a piece of that, about as long as the space that you have to fill in, and we're going to apply that to the bag. All right. So what we've got now, you see my fingers in between there. We've got the glass with sealant tape, we've got the bag with sealant tape. So now it doesn't matter if there's excess bag material there. What we're going to do is work the two edges together. And now you've got a good seal, all right? Yes, there's extra bag material here. Doesn't matter. Because now we're going to hook up the hose to the vacuum takeoff fixture. We're going to hook this in to our vacuum pump. And we're going to pull a vacuum on the part. Now, if you look closely, what you'll see is that, you see in this area, there's little dots, dark dots. That's where the resin is coming up through the perforated release layer and soaking into the breather cloth, right? In this area is where the peel ply was. So it's coming up in a much more general fashion, just bleeding through the peel ply, and that peel ply is becoming part of the laminate. In this area, there's no resin bleed whatsoever because the mylar is there, and it's going to give that slick surface, okay? You see the bag is down extremely tight. The air is evacuated from this, and the atmosphere is pushing down on it. That's what vacuum bagging is all about. Atmosphere is exerting pressure, 27 inches of mercury or so, whatever atmospheric pressure is, it's exerting it down onto that part and compressing those layers together. That's how you get a strong structure. Now, what I would do with this right now, normally, is I would keep this under vacuum, okay? This hose is high temperature capable hose. This, as it sits right here, would go into my curing oven and sit there until this resin gelled, okay? When the resin gels, then I can take it out. But I would keep it under vacuum just like this. It's very tempting for some people who are doing vacuum bagging for the first time to at this point say, well, I'm vacuum bagged, shut off their pump, pull the hose, and go put it in an oven or whatever, you know, just let it sit. What's going to happen if you put this in an oven right now there is a little bit of outgassing from the epoxy resin as it cures. What it's going to do, or if you just let it sit, if you look in here, looks like ice crystals coming in. That's air coming back in to the bleeder breather layer. Your part that was under vacuum is no longer under vacuum. Air is getting in there, and now look, I can start to pull this up. Air is getting back in, so leave it under vacuum and get it into your curing oven. Kick it off, then you've got a good thing going. I'm going to take this right now and set it aside and get the same structure that we've made here in a cured state, and we're going to take it apart and see how it works that way. Okay, here is the same structure in a cured state. What you do is get up a corner of the vacuum bagging sealant tape. It's tough stuff, very sticky. But you get up a corner of it and you just rip off this whole bag material. All right, get the bag material off. And you'll see the bag material doesn't stick to epoxy either, so it's all coming off nicely. This is what I meant. This is what I meant by when I said there's a lot of disposable stuff with this process. This is obviously used once and once only. There are reusable vacuum bag systems on the market that use silicone sheet. They're very nice, and they are an alternative if you want to put out more than one part. You know, if you want to do this on a regular basis, you can do this. And now I'm going to peel up the bleeder and breather layer and get into that. Actually, I'm going to get in here with a little spatula and try and get in. You notice it's the resin dam has done its job, and it's held the resin pretty much in the right area without it getting to the vacuum valve, right? So now we're going to get in there and get that bleeder and breather off of our part, right? Just pulling off the resin dam. All right. Notice the bleeder breather is coming right off of the mylar area and the peel ply area and the release coat or release material area. All right. So we're kind of doing a little archaeology here, unearthing our finished laminate that's under here. Now, I just peeled off the peel ply. I just took off the mylar. And now I'm going to take off the perforated release layer. There's our part. Going to try and lift up one corner. And just work our way all the way around the part and release it right up off the glass. All right. All right, there we go. Now, here is our finished vacuum bagged plate structure. This is about a 1/16 of an inch thick, and it's pretty strong for what it is. You notice we've got a pretty smooth finish here, and that's from using the non-woven. But there's our plate structure. You just use as many layers of what you need to build up that plate structure. On this side, we have a smooth finish here from the mylar. We have a peel ply finish here, and here we have a release finish layer. It's got little dots in it where it was pulling the resin out. This is also probably a little resin pour. It's pulled a lot of the resin out, maybe too much in this area. What you would do in that case is you wouldn't want to use a perforated release layer there. You'd want to use a peel ply layer. Peel ply doesn't allow so much to transfer. But that's how to make flat sheet stock, right? Okay, on to the next project. Our next project is going to be the Aerobee fin. Now what I've got here is a mold. It's half of an Aerobee fin. All right? It's an Aerobee fin that's essentially a mold, a two-piece mold has been made off of. One of each half. All right? What we're going to do here is apply our sealant tape so you can get an idea what this process looks like with the sealant tape. I'm not going to use a resin dam on this part because I've got a good flange width here in which resin won't travel that far. I just know that from experience, so I'm not worried too much about a resin dam on this part. So all the way around the outside, we're going to go with sealant tape. All right? Just around the outside of the part. And here I've run out of a roll. Did it on purpose to show that you can just run the sealant tape out like that. You can add more sealant tape. I mean, the stuff really is literally like silly putty in that you can just add more and it'll stick to itself and it'll seal off just fine. So I take a piece about this long and just put it onto the end of where it left off. Right? Then I'll peel the paper up from where I started, overlap that sealant tape, and now we've got a good sealing structure all the way around the mold. I've got a different type of vacuum bag here. It's pink. It's just because it's a slightly different material. Still going to serve the same function, just a slightly different material. I'm also going to get our vacuum takeoff valve from our last project. I'm just going to take it out of that bag so we can use it again. There's our vacuum takeoff valve. We'll mix up another batch of epoxy. Okay. Notice we're kind of working our way up on the level of relief in structures here, from a flat plate up to a flat kind of surface, a fin, but it does have some actual bevels on the front and back of it. I'll be able to show you that in the finished part easier than in the mold. But and then we're going to work up to the nose cone half. So let's get this. Get the hardener in this mix. There we go. Okay, and we will mix, mix, mix. Again, this side of the mold will be treated with release agent. You can use the wax release agents like Meguiar's, the Carnauba wax. That's a little bit longer process, again, of applying it and then buffing it, applying it, buffing it, you know. So You need to do at least 6 applications if you're going to use a carnival wax. I like to use this PTFE spray. It's a little better in high heat applications. In the heat application, meaning that this structure will be going into a curing oven. I like to use a curing oven because it obviously allows me to kick off this laminate in an hour or so, and then post-cure it with another hour in the oven, roughly, and that then allows me to get on to the next part a lot quicker. But that's got the release agent in it right there, or on the mold surface. So let me get some gloves on here, and we will go to the laminate. This is going to be the same, using the same materials. We're going to again use carbon fiber because I want ultimate lightweight, and I want a good stiffness for the amount of weight that I'm putting on there. So that's why we're going to use that. I'm also going to use the non-woven material as the first layer down on the mold. It's when it's removed from the mold, it's the first layer you're going to see. So we'll get that, get a layer of that down on there. I'm doing a few things differently here. What you're going to notice, get this off to the side there. What you're going to notice is that I've got a couple layers of this non-woven. Actually 3 layers of the non-woven, okay? The first 2 layers fit exactly in there, exactly the fin shape, okay? What we have to do is create enough material that's just down in there in the fin shape to fill it up. This has got a wall on the mold that's about 1/16 of an inch thick. The total fin is 1/8 of an inch thick at those leading edges and trailing edges. So this is 1/16 of an inch. What I want to do is plan this laminate so that by the time it gets out to that edge, it's 1/16 of an inch thick. I want solid material out there. I don't want air bubbles, I don't want little things. And that's what happens when you try to get material down in there and up and overlap. You just want it to come to the precise limits of the part, okay? So I'm painting it with resin. All right, painting the resin. Now we will lay in the 2 layers of non-woven that are precisely cut to fit into this fin shape. And this is a full-size Astra Beef D fin again, so now it's fitting precisely in there. Very nice. Okay, we'll add a little more resin just to keep things tacked down and happy. Whoop, getting a little out of alignment, so just get it back. That's good. All right. Now you see that's sitting right in the exact shape. I trim these very carefully, and they're sitting in there doing exactly what they need. By the time these 2 layers come out to there, they're going to be about 1/16 of an inch, or no, I've got a 3rd layer to add in actually, and by the time that's in there, it'll be a 1/16 of an inch. And the 3rd layer is also going to overlap a little bit on the outside parts of the mold to create a nice flange so I can go in there and pop it out after the part is cured. And then that flange is just trimmed off later. So. All right, those are good. Now you'll see that this overlaps the bottom layers by a little bit. It's still cut inside the part over here on this edge and on this edge because, see, on this edge, the root edge of the fin, it's like 0.4 of an inch thickness. So I'm not going to be able to get in there and get something to stay down on that surface, then climb up this wall, then climb on that wall. No matter how, you can do it if you use a thing called a caul plate, which is something in the shape of this fin that would, a material with that same bevel and everything to it that you would put in as part of your final assembly after the release layer is on. You put that caul plate in there and it would help to push it down into the recesses. So you can get it to climb walls and do things like that. It's just not something that you want to do if you don't want to put a lot of effort into it, because making that caul plate, you know, it's going to take just another step of tooling and stuff, but you can do it if you want. You can also use a caul plate like that on flat structures like the first one that we did to help smooth it out. What I wouldn't do is, I talked a little bit about people weighting laminates between two layers of glass. That's very dangerous, actually. If you want to do that, you can get away with it, but keep a very good release on both layers of glass, or when you go to pull that second layer of glass off of the laminate, it's going to shatter. So just be careful. So here, we've got the first layer of 8-ounce carbon going in, and it's cut exactly to fin shape. So it's going in right where the first two layers went. All right. Again, I'm not too worried about impregnating the cloth 100%. It's gonna do it as part of the process of being vacuum bagged. So just get a good amount of resin spread in there in a good dispersion across the surface. Now we'll get to our second layer of 8-ounce carbon. All right, same type of effect. Just get a good amount of resin on there, on the surface. Okay. Third layer of 8-ounce carbon. All right. Just getting the resin spread over. Good general spread of resin over the surface. Okay. Now, that's all of our carbon. That's all we figured that we needed for that laminate. So now I've got a layer of the perforated release film. Okay, that goes down directly on top of the laminate, overlapping all the critical areas. Okay. Then our layer of bleeder breather. Same as in the first go at it, right? I'm going to turn this around because the area where I want my vacuum valve is right up in here. So right, and there we are. Now you'll notice I pre-cut all the materials before the lamination. You don't want to finish the laminate and then come in and start cutting materials. Get it all ready to go, okay? Before you start to laminate. I would then go just like with the first process, attach my vacuum takeoff fixture right through there, take off the outside sealant tape, attach it, go, okay? You use the same technique that I showed with the extra sealant tape to take up any extra bag. Okay, I'm going to put this aside now because all that's involved is sucking the vacuum on it that we showed in the first one. So we'll put this aside right now, and I'll show you the finished result. This is the finished result. This is a full-scale Astra BD fin executed in carbon fiber, both sides. It's got a taper from 0.4 of an inch at the root down to 1/8 of an inch at the tip. It's also got bevels running at the forward extent and the aft extent of the fin. A fairly complex fin shape, but they're two sides taken using the technique that I just showed and then bonded together. Okay? It's filled with a material called a syntactic foam, which is a very lightweight, strong epoxy foam, and it doesn't swell up so it wouldn't blow the parts apart. It's just enough to get in there and bond those parts together. And this is extremely strong and very, very light. So if the original Astra B guys were still around, maybe some still are, I bet they'd like to use a fin like this because of its lightweight instead of the aluminum that it was probably made of, or steel. So there's an Astra BD fin. Okay, now we're going to go into the third part of the vacuum bagging instruction. And what I've got here is a half of a mold from a 4-inch conical nose cone. It's the same nose cone that was used in Frank Cosden and I's 40,000 foot altitude rocket. So what I've done is gone in to the mold, and the red is the mold, and the white that you see is a material called a surface coat. It's an epoxy-based surface coat. If you were in a polyester system or using a polyester resin system, it would be called a gel coat. But this is called a surface coat when it's epoxy. So I've gone in there and put on a layer of the epoxy surface coat. What this helps to do is give a nice white finish to the part right out of the bat. And you can also have a little bit of the shoulder transition area here. You know, it just helps to make it a little more gentle. We're gonna take an extra step to make that a little more gentle as well. But so that's how the mold is prepped. Before the surface coat was added in there, of course, it was sprayed with the mold release as well. So this is, as you can see, a fairly good depth part, and I'm going to show you the differences involved in vacuum bagging a part with depth like this. So, okay, we'll get going. We've got our resin mixed up and ready to go here. So we'll just add a layer of resin. Notice I do that on all the parts. You don't want to lay the material in dry and then add resin on top of it. There's no guarantee that it's actually going to migrate down, you know. So if anything, under vacuum it's going to migrate up and out. So you want to get a healthy application of resin down in there. Now this nose cone I'm going to make using Kevlar and fiberglass instead of the carbon fiber. You can make them out of carbon fiber as well. The one on the altitude rocket was made from carbon fiber, but I'm just doing it out of Kevlar just to show the differences used in using that material. We've got the surface coat, right? So the Kevlar now will go down in the area of the shoulder, okay? That shoulder is a notch, okay? You don't want to make material, like I explained in the last go-around, go up and climb walls and do that kind of stuff, because what it'll do, it'll bridge and it'll bubble, and you'll get air bubbles in there. And it never performs precisely how you want it to. So you have to make allowance for that. The way you do that is by cutting strips and essentially ramping, creating a ramp for the first layer of cloth that's going to go in. So this strip is in there, and that's butting right up against the shoulder in the mold, okay? So that's in there. I'm just adding a little bit of epoxy over here to keep this out of the way. It's not, you know, it's outside of the mold, so it doesn't matter. But we got that little piece in there, and now a thinner piece. It's the same technique that's used as when you're doing fin fillets. You want to create a kind of staggered approach, so it all ramps in once it's all together. So that butts up right against the shoulder. Okay. There we go. Also with Kevlar, use a little bit more resin than you normally would. Kevlar is tough to get wetted out, so use a bit more. Okay, so the Kevlar's in. Now I've got a solid layer of Kevlar that's going to go on the whole nose cone, and because we have these transition layers, it's going to go right over the shoulder nice and smooth. We won't be asking it to do any gymnastics to get into that shoulder area, right? So I just kind of lay it over, and I'll start at the tip and just kind of lay it down right into the center, right? These pieces are all carefully pre-cut to fit in there as accurately as possible. You don't want to be cutting material as you're laminating. Get it all cut beforehand and assemble a little kit of stuff that's going to go together in the sequence that you want to lay it into the mold. Now, you know, a lot of people don't like working with Kevlar because you can't sand it. Well, you're right, you can't sand it, so why are you trying? Don't try to sand Kevlar. Don't make it the finished outside layer of your laminate. If you use it in a structure like this as the second layer behind surface coat, if you need to do any sanding, you're sanding the surface coat, which sands great. Don't put yourself in the position when using Kevlar of having to sand it. I mean, an occasional little trim on it is fine. Your diamond wheel will accomplish that. And then if you do have few frayed pieces of Kevlar, freeze them up with CA glue or a cyanoacrylate, and then just keep sanding and freezing and sanding and freezing, and you'll get those little Kevlar fibers or aramid fibers. You know, you'll get them trimmed down to size, and you'll get a clean edge on the part. But you don't want to be doing too much of that. That's obviously a lot of work. So Kevlar is a wonderful material. Impact resistance, superior stiffness to glass, lightweight. It's a great material, and too many people are afraid of using it because they don't want to sand it. Well, like I said, don't put yourself in a position where you have to sand it. Engineer it correctly. Now we're going over the Kevlar with a layer 5-ounce glass. Right. This is a satin weave, so it's kind of light and flexible looking. I'm using a satin weave here. I could use a plain weave here. The Kevlar was plain weave, but I'm using a satin weave glass just to show that you can. And you know, satin weaves are a little more flexible. And no, this is a good application for a satin weave because it's a circular part in cross section. You know, it does well with a little more flexible material. So it's a little bit chilly out here today. My resin is a little bit thicker than I'd like. So it is taking me a little bit longer just to carefully work down this glass layer. But you'll notice it still is going right through the glass and impregnating it, soaking right through it because it's coming through the banana yellow color of the Kevlar. So it's working. So I just continue to wet out that layer. All right. I'm just going to add a little bit of extra resin, top to bottom. Remember, in vacuum bagging, you can use a little extra resin. Go ahead and use it because it's going to be bled off later. and you want to make sure that that Kevlar and that glass is all thoroughly saturated, thoroughly wet out. Okay, so we'll get the next layer of glass on. I always start at the tip with nose cone shapes. If you start at the base or the shoulder, by the time you get up to the tip, you'll probably be way out of whack. The weave likes to throw you a curve sometime. So start at the tip, the skinny portion, and then just slowly work your way back. Okay, you'll see the Kevlar is just hanging out. That's fine. Don't need to do anything special with it. In this case, where those just two narrow strips are there to ramp over the shoulder, the vacuum bag will suck them down to that hard edge. So, I like to cut the strips on the inside of a cone, though, to fit within the confines of the cone shape. I don't like to pull it out of the cone and then ask it to go over the edges and make a big side transition. The more you do that, the more it's going to want to make air bubbles along that corner, that sharp corner right there. So I like to do it this way. You can, however, make it go up and over. Just be aware that you will have more air bubbles to fill. Okay, we're looking pretty good with the glass over the Kevlar. Give it a little more resin. Right. Now what we're going to go in with is our perforated release layer. You could also use peel ply here if you want to keep down the amount of resin that's bled out. I'm using perforated here. It's either or, all right? And we just lay it in there so that it's contacting as much of the surface as we can get. You don't want to get it so it's bridging over too many areas. Sometimes that can actually get bound up as you're trying to pull a vacuum on it and cause an air pocket in there. So just get too much material down into there. That's always a safe bet. Okay, then we come with our breather bleeder. And with this, you'll notice I didn't apply any of the sealant tape to this mold. That's because we're going to do this as an envelope of vacuum. We're going to pull vacuum on the whole mold and the whole part, okay? What this bleeder breather is sized for, you see I'm putting it down into the cone shape, but it's sized also to wrap around the edges of the mold. That's in case you have any spare glass fibers or carbon fibers sticking out of the edge of the mold that might puncture the vacuum bag. You want to protect the bag from those. So the whole mold is wrapped with this stuff. And make sure that you've got enough down in the cone shape itself. So then what I've got here is a bag already prepared. All right. I've got the bag, and you see it goes all the way around. And on 3 sides here, I've got it taped up with the sealant tape. Okay? This side doesn't have the sealant tape. All right? I'm just going to grab a knife here, and then we're going to puncture the bag so that we'll have a vacuum takeoff area. Okay. We've got the mold with the bleeder breather in there, right? I've also got a few extra layers of the bleeder breather that we're going to put in one corner of this baby, so it will so that we'll have an area that's good for, you know, to keep the resin out of the system, like we did on the first one. So we've got that. Let's get our vacuum takeoff unit in there. Okay. You notice this this vacuum bagging material is a light blue. This is actually a very high temperature material. Just showing you what different kinds there are. There's about 100 different kinds. There's also very stretchy kinds and all kinds of different vacuum bagging materials. Places like Aircraft Spruce will be able to help you as being suppliers of vacuum bagging materials. It's a very low margin material, you know, not much money to be made on it unless you buy in huge quantities. And I particularly don't want to be a vacuum bagging material supplier, so I'll just send you to those guys for the vacuum bagging supplies. Now you know what they are and how they're used, you'll know what to buy. And if you have any questions, further questions, just email us and we'll be happy to answer whatever questions you have and lead you in the right direction to get you what you want. Now notice when I'm going to seal the bag here, I'm only going to come a few inches here. I just want to start it on either end, okay? Because what we have to do in this bag is we have to allow some extra bag to suck down into that shape, right? So I'm only coming a few inches on either side here, right? And then I'm going to jump over this and we're going to do the long edge, okay? I've got these extra little pieces in there underneath the vacuum takeoff valve, so be sure to get that in position. Okay, so I've jumped over and now I'm sealing the long edge. All right. While these materials are all basically one-time use and disposable, they are fairly cheap. It's not a huge investment to do it. You know, vacuum bagging can be done. The pump can be gotten for $75 to $100. You can even get surplus deals on eBay or other services like that. And you know, you can assemble the rest of the stuff from hardware store type sources, and then you get your vacuum bags and you're set up and ready to go. So it's not that tough. Now we get a little bit more of our sealant tape, and we'll just take a couple 6-inch lengths or so. And I'm going to do that kind of bridge technique to get extra bagging material in like I did in that first one. But you'll see here I'm going to get much more material in as I pull this extra tape here, add this tape to the top. Let me pull it around so you can see what I'm doing. And zoom in on this. You can see there's sealant tape on the top, there's sealant tape on the bottom. Now as it goes together, I've got a lot of extra bagging material up in here. And these just come together like that. And it makes an airtight seal. We'll do that also to the bottom edge down here. Okay, now we're all together. Looking pretty good. I'm just going to take one last trip all around the outer perimeter of this. Make sure I've got it good and squished down and got a good seal. Sometimes when you pull a vacuum on the part, you'll actually hear hissing, and you'll find that you don't have a good seal. And just keep working your way around the outsides until you find where that hissing is, and then compress the area with your thumb and forefinger and smush it into the sealant tape, and you'll have it. So now we're ready to pull vacuum. So let's go ahead and pull vacuum. And with this, what you're going to do is you're not going to pull all the vacuum at once. You're going to kind of sneak up on it just by plugging it in. See this? It's starting to pull the vacuum. But what am I doing? I'm gathering that bag up in the middle. Right? It's right over the concavity in the part. Okay? I need extra bag in there for it to be able to pull in. If I don't have that extra bag in there, it's going to bridge over the part and not suck down into it and not compress it. So we need that extra bag material in there. So I've got this extra fold, as you see, right over the center of the cone. All right? And now it's starting to pull down in. And look at it go. All right? It has now pulled all the laminate into real intimate contact with the rest of that surface coat that was in the mold. You can see also with the perforated release layer, that resin's starting to come up. The excess resin is starting to come out of the laminate. All right? Pull it up so you can get a real good look at it. This is what vacuum bagging is made for. Parts with a lot of contour. Using this technique and making sure you've got folds to get enough bagging material down into there. Also, if there's a shoulder area, or somewhere you want to really drive that stuff down in, put a fold over it. That will enable the bag material to really compress it down in. So be careful where your folds are. If you don't have your folds just right, let the vacuum off, kind of readjust them and suck it down again. But now this part would go into an oven for cure. So we'll take it off vacuum and I'll show you what we get. This is the other half of the same mold with the same Kevlar part. And we'll just go in and start to release it. And it should pop out any time. There we go. And this half of the nose cone is out of the mold. You see the white surface coat layer, and on the inside you see the Kevlar. Okay? That's a strong piece for half a nose cone. When you go and you make the two halves, then obviously you make sure the join lines are all trimmed and nice so you can join them together. And then you'll go back, you tape the two halves together, and you run a bead of epoxy. You just let it drip down all the way to the tip, right along the seam. And then you can come back in with a long dowel and just apply a tape, a thin layer of glass tape in there, and just laminate it for the whole length of the cone. Then you'll have a complete cone like this rocket. So, using this technique, you can do some beautiful things. This is the nose cone from the Trinity rocket. That's the Advanced Composite Technology demonstrator rocket that we made. It's still got dust on it from the last launch. But as you can see, that's a beautiful cone. And it's made using a hybrid cloth of carbon and Kevlar and an epoxy matrix. The technique that I used, that I showed you there, of using the bands of material to create the shoulder on it, on this cone it's created using bands of carbon fiber. So you can do some beautiful stuff with vacuum bagging. And I hope that this video has served to help you out with some of the details and get you started on the road to using it effectively in your projects. Thanks a lot, and God bless.